welcome to Next Gen Manufacturing Nexus. Today, we are diving deep into something that's, well, it's a revolution happening at the molecular level. We're talking about smart materials. So let's jump right in.
All right, just take a second and look around you. The stuff that makes up our world, the concrete in the buildings, the metal in our cars, even the plastic in your phone, it's all kind of static, right? It just sits there and does its job until it breaks or wears out. It doesn't react, it doesn't adapt. Honestly, it's pretty dumb.
And because of that, we live in this world of constant repair and replacement. I mean, we see it all the time, right? Cracked phone screens, those potholes that never seem to go away, and big stuff like infrastructure that's just silently aging, waiting for something to go catastrophically wrong. That's the big fundamental weakness of pretty much everything we build with.
But what if that could all change? What if the very materials we build with could sense what's happening to them? What if they could react to it, or even, get this, repair themselves? What if our materials finally got smart?
And you know what? This isn't some far-off sci-fi dream. It's happening right now. We are standing right on the edge of the smart material revolution. We're talking about a whole new generation of materials that basically have intelligence built right in, ones that can adapt to what's happening around them in real time. So, okay, what is a smart material, really? Well, at its heart, it's pretty simple. It's any material that can sense some kind of trigger from the outside world, like heat or pressure or even light, and then it responds by changing something about itself. Maybe its shape, its color, its stiffness. The key thing to remember is this: it can sense, it can respond, and it can adapt. This right here, this is the fundamental idea. An external stimulus triggers a very specific response. So let's take a look. If you apply physical stress to say, a piezoelectric material, think of it like squeezing a crystal, it actually generates an electric charge. That's the spark you see in some lighters. Or how about this one, an electrorheological fluid? It's a liquid that can go from runny to almost solid in an instant when you hit it with an electric field. Imagine that for instant shock absorbers. This direct cause and effect, that's what makes it smart. Okay, so that's the principle. But what does this new toolkit of tomorrow actually look like? Let's dive into some of the most mind-blowing categories of smart materials that are out there right now. All right, remember how we started with the big problem of everything breaking down? Well, what's the most direct, most incredible solution you can think of? How about materials that can just heal themselves, autonomously fixing damage, extending their own lifespan, all without us having to lift a finger? And this lays it out perfectly, the before and after. On the left, you've got our world today, a crack forms, and you got to call someone and pay a bunch of money to fix it. But on the right, that's the future. You've got these tiny little microcapsules or tubes embedded in the material. A crack forms, breaks them open, and boom, a healing agent is released, it fills the gap and hardens up. Problem? Meet your autonomous solution. And the places we can use this? It's just incredible. Think about it. Concrete for bridges and highways that literally heals its own cracks. The maintenance savings would be astronomical. Or what about car bodies that can fix minor dents and scratches just by applying a little bit of gentle heat? This isn't a fantasy. This stuff is being developed right now to build a much, much more durable world. Okay, let's switch gears to another almost superpower-like property. What if a material had a memory? Imagine taking a piece of metal, bending it completely out of shape, and then with just a little nudge, it snaps right back to its original form, like it never happened. Well, that's the magic of shape memory alloys, or SMAs for short. These metals are really cool. They kind of have two personalities, or two different crystal structures. When they're cool, they're flexible, and you can bend them all you want. But as soon as you heat them up, they go through this change and powerfully spring back to their memorized shape. It's like a built-in reset button. And again, the applications are a total game changer. In the medical field, they make these tiny stents that can be threaded into a blocked vein. Then your own body heat is enough to make it expand to its perfect functional shape. They've used them on the Mars rover to move solar panels. And you might actually be wearing this tech right now if you have those super flexible eyeglass frames that you can bend all over the place. So we've got materials that can heal themselves and materials that can remember their shape. That's already amazing. But what if they could react to their surroundings instantly, like changing color on the fly to give us information, or just to adapt to what's happening? This is where chromogenic materials come in. The name gives it away, right? Chromo means color. And that's exactly what these do. They change color when something specific happens. You've got thermochromic materials that react to heat, photochromic that react to light, and electrochromic that react to an electrical charge. Simple as that. And I guarantee you've seen this stuff around. Those glasses that automatically turn into sunglasses when you go outside, that's photochromic tech. But it goes way beyond that. It's the key to smart windows that can tint on command, which could save a fortune on energy bills. Or even something as simple as food packaging that changes color to let you know if your food has gone bad. Super useful.
Okay, so these individual materials are clearly amazing, but their real power, their true potential, is unlocked when we start putting them together. We need to think bigger. Let's scale this whole idea up from smart materials to smart megastructures. And this is the big leap in thinking. A smart structure isn't just a bridge made of smart concrete. The structure itself becomes a smart system. It's the whole shebang, sensors to feel, actuators to move, and a control system to think, all working together as one big, intelligent unit that can react on a massive scale.
And this is where things get straight out of science fiction. We're talking about airplane wings that literally morph and change their shape while flying to be more efficient. We're talking about bridges that are constantly checking their own health, using tiny sensors to feel for stress and damage and reporting it back before it becomes a disaster. Or how about skyscrapers with dampers that can react in a millisecond to stiffen the building against an earthquake? It's incredible. Look, this isn't just a minor upgrade. This is the kind of technology that completely rewrites the rules for entire industries, everything from aerospace to construction. This is, without a doubt, the next manufacturing frontier. Okay, so if this stuff is so amazing, you're probably asking, why isn't everything around us already built with it? And that's a fair question. Like with any truly groundbreaking tech, there are some pretty big hurdles we still need to clear. This table really lays out the push and pull. On the one hand, the upside is massive. We're talking enhanced sustainability, more resilience, better safety, and huge cost savings in the long run. But the challenges are real too. The initial cost to make this stuff is high. There are still questions about how durable they'll be over, say, 50 years. We don't have industry-wide standards yet, and figuring out how to integrate these new materials into our existing world, that's a huge puzzle.
But the path forward is definitely getting clearer. The next giant leap isn't going to come from just one of these fields. It's going to come from convergence. Imagine combining smart materials with nanotechnology to control them at the atomic level. And then layer on artificial intelligence to make sense of all the data they're collecting and make smart, predictive decisions. That's how we get past the hurdles. That's how we unlock the real full-throttle potential here.
And so that leaves us with a really big, kind of mind-bending question to think about. This isn't just about making a better kind of concrete or a cooler type of metal. This is about changing our entire relationship with the physical world we build. So I'll leave you with this. When everything around us, our buildings, our cars, our clothes, can sense, heal, and adapt, what new worlds will we be capable of building?